Hello and welcome. In today's tutorial, our task is to find all the values of x that satisfy this equation. But before we can do that, for illustrative purposes, I'd like to write this equation in its exponential form. We have that 8 log x is equal to, we take this over to the right hand side and we have x. Now we divide both sides of this equation by 8 and we have that log x is equal to x over 8. Now you know that when we write log without specifying the base, it means we are working in base 10. And written as an exponent, this equation is simply 10 raised to power x over 8 is equal to x. That is 10 raised to power x over 8 is equal to x. Now you know that when we solve exponential equations, usually what we do is to manipulate the equations until we get to the form a raised to power x is equal to b, where a and b are real numbers. Then we take log of both sides and we end up with the solution x is equal to log b divided by log a. But notice that in this case, we have x, the unknown, both in the exponent and outside the exponent. So we cannot simply take log of both sides. In cases like this, where we have the unknown both within the exponent and outside the exponent, the function we use is called the Lambert W function or the product log function. But before we can apply that function, we must get this equation to look like w e raised to power w is equal to some real number c. That is, what you have before e must be the same thing as the exponent of e. Now let us solve this equation so that you can see what I mean. The first thing we do from here is to take the natural log of both sides. And when we do that, we have that ln 10 raised to power x over 8 is equal to ln x. Of course, you know that we can bring down this exponent to multiply. And when we do that, what we have is x over 8 times ln 10 is equal to ln x. Next, we divide both sides of this equation by x. When we do that, we have that ln 10 divided by 8 is equal to ln x divided by x. Now, you know that when x is dividing, we can write it as x raised to power minus 1. And this is multiplied by ln x. Here we have ln 10 divided by 8. Now next, remember that when we have e raised to power ln any number m, that this is simply equal to m. So we can write this x as e raised to power ln x. And then remember the raised to power minus 1. So we have raised to power minus 1. And everything is multiplying ln x. So writing this in the proper form, we have that ln 10 divided by 8 is equal to, we have ln x multiplied by e. Remember that when you have a raised to power m, that it's simply equal to a raised to power m times m. So to open this bracket, we multiply minus 1 by ln x. So we have e raised to power minus ln x. Now notice that we already have ln x here and we have ln x here. The only thing that is lacking here to make what we have before e look like exactly what we have in the exponent is this negative sign. And how do we introduce that negative sign? By multiplying both sides of this equation by minus 1. So when we multiply both sides of this equation by minus 1, we have that minus ln x e raised to power minus ln x is equal to minus ln 10 divided by 8. Now, notice that what you have here is exactly the same as what you have in the exponent of e. So now we can comfortably apply the Lambert W function to both sides of this equation. But before we do that, we need to use our calculator to evaluate this. And when we do that, we have that minus ln 10 divided by 8 is equal to minus 0.2878. Now, when you apply the Lambert W function to this, what you simply have is this. So we have that minus ln x is equal to, we apply the Lambert W function to this also. We have Lambert W function calculators online that you can use. What you simply do is to plug this number into the calculator. Now, when this number lies between the range minus 1 over e and 0, the Lambert W function calculator will return two numbers. In this case, we have that minus ln x is equal to minus 1.8731 or minus 0.4525. Now, of course, we have negative here and we have negative here, so they can cancel, giving us that ln x is equal to either 1.8731 or 0.4525. And of course, you know how to solve this equation. You know that when you have ln x is equal to a number, it simply means that x is equal to e raised to power 1.8731 or e raised to power 0.4525. And when we evaluate this with a calculator, we have that x is equal to 6.507 or 1.572. So the two values of x that satisfy this equation are 6.507 or 1.572. And with that, we come to the end of today's exercise. Remember to subscribe if you enjoy such content. Leave us a thumbs up to support the channel and see you in the next one.